This will be our last lesson for chapter 3, and it's section 3.8 in your text. And this one is factoring special polynomials. So these ones are special. You need to recognize them and then be able to do them in a different way. So what you're going to be able to do is to be able to identify or recognize a perfect square trinomial. You need to be able to identify or recognize a difference of squares. And then once you're able to identify them, you need to be able to factor each of them. And finally, you're going to be able to factor a two-variable trinomial. So when there's x's and y's mixed up in one question. We're going to first look at perfect square trinomials. And you need to be able to identify what a perfect square trinomial is, because once you can identify it, it's easier to factor. So we say something is a perfect square trinomial when the square root of the first term, so the first term, and the square root of the third term, are doubled. So if we take the square root of each and double them, it equals the second term. If that happens, it's a perfect square trinomial. So for example, the square root of the first term is a. The square root of the third term is b. Now if we take those and double them, it equals the second term. So ab is ab, and double it, and you can see that the square root of the first and third term multiplied and doubled equals the second term. So this is a perfect square trinomial. Another example would be 4x squared plus 9x, plus 12x plus 9. This would be a perfect square trinomial because the square root of the first, square root of 4 is 2, square root of x squared is x, square root of the last term, square root of 9 is 3. Now if we multiply them together, 2x times 3x is 6x. And don't forget to double it, is 12x. And so you can see that when we square rooted them and multiplied them, doubled them, we got the middle term is 12x. So this is a perfect square trinomial. And now to factor it, all we need to do is we take those square roots and we take the sign in front of b, and it's those things squared. So 2x plus 3, 2x plus 3 squared will be our answer. So maybe one thing I need to mention before we go on is this is a perfect square trinomial. Now we could do this using the methods from lesson 3.6. What multiplies to 25 times 16 and adds to 40. The problem is those are some really big numbers. If we recognize it as a perfect square trinomial, we can do it a lot quicker. A hint to look for is we're looking for perfect squares. So I'm looking for these numbers. 4 is 2 times 2. 9 is 3 times 3. 16 is 4 times 4. 25 is 5 times 5. 36 is 6 times 6. So on and so on. 7 times 7 is 49. 8 times 8 is 64. So on. So 25 and 16, it's a hint to me that this may be a perfect square trinomial because it's using perfect squares. So let's try it. Square root is 5. Square root is 4h. Now it is a perfect square trinomial if I multiply these and double them to get this. 5 times 4h is 20h. Double it is 40h, and there it is. So it is a perfect square trinomial. So now just like I showed in our last example, my answer will be this, the symbol in front of b, and this squared. So our answer is 5 plus 4h all squared. Now we're going to look at a difference of squares. So first you have to think, what is a difference? What's the difference between 5 and 3? In your head you should be subtracting. So sum is add, difference is subtract. So we're looking for a difference, so subtracting squares. We're looking for perfect squares. Again, 4, 9, 16, 25. So a difference of squares is when you subtract one perfect square from another. Example, 4x squared minus 9. We're subtracting 4 is a perfect square, 2 times 2. X squared is a perfect square, x times x. 9 is a perfect square, 3 times 3. And now the factored form is two binomials. So it's going to be two binomials using a plus and a minus of the square roots. So first, I can recognize this as a difference of squares because they're both nice square roots. Square root of 4x squared is 2x. Square root of 9 is 3. And it's a difference because it's subtracting. So my answer is simply 2x and 3, once with a plus, once with a minus. So 2x plus 3, 2x minus 3. If you were to FOIL this, the reason there's no middle piece, we're used to having trinomials where it'd be an x squared, an x, and a number. What happens is if we were to FOIL this, 2x times 2x is 4x squared. 2x times minus 3 is minus 6x. 3 times 2x is plus 6x. 3 times negative 3 is negative 9. And hopefully you can see that a minus 6x and a plus 6x cancel each other out. So you're just left with the 4x squared minus 9. Now if you see this, not a difference of squares because it's using a plus, and a difference must be subtracting two perfect squares. So our third special polynomial today is two variable trinomials. Again, tri means there's three terms, and it's two variables because we're mixing w's, wx, x's. So you're used to seeing something a little more like this. It might be 4w squared minus 8w's minus 21. And we've worked on this the last few days. What multiplies to negative 84 and adds to negative 8? Well, all they've done here is they've added an x and an x squared. So it means there's an extra variable in our equation. The steps are going to be the exact same. I'll show you once using the long way, once using the quick way. So first, what multiplies to negative 84? And so negative 84 would be 84 times 1. It would be 42 times 2. I'm thinking it's going to be 14 and 6. So if I use 14 times 6, 14 times 6 is 84. 6 minus 14 is negative 8. So I'm going to use 6 and negative 14. If you go back to the last videos, I showed you how to work out all of them. I'm just going quicker here. So negative 14 times 6 is negative 84. Negative 14 plus 6 is minus 8. So now we take our original problem and we break our middle term up into our two new terms. So minus 14wx plus 6wx minus 21x squared. And we cut it in half. So step one was what multiplies to AC and adds to B. Then step two is we take our two values, break up the middle term, and cut it in half. Step three was factor what these have in common. 4 and 14 share a 2 in common. W squared and W share a W in common. So 4 divided 2 is 2. W squared divided W is W. 14 divided 2 is 7. W and W gone. X is still there. And now whatever I got here, I need to get on this side. So I need to get 2w minus 7x. Now to get 6wx into 2w, well 6 divided 2, I'm going to take out a 3. W divide w, the w's going, and the x needs to stay around. So now, and if you're not sure, check. 3 times 2 is 6. W times w is w squared. So I have done something wrong, okay? What I did is I need to take out that x. So now check it. 3 times 2 is 6. X times w is wx. We're good. 3 times negative 7 is negative 21. X times x is x squared. I'm good. So now the two parts outside of the brackets, make a new bracket. And the brackets themselves, we use one of them. And there's our answer. If you are going to use the short method for this, remember you still must do this first step. We need negative 14 and 6. But the short method was take two brackets. This value without the squared goes at the front. Now we're going to use minus 14 and 6. So we put in minus 14 and 6. The difference now, though, is this extra variable goes at the back of each. So I need both of them to have an x. And now, whatever they have in common inside a bracket has to go. 4 and 14 have a 2 in common. So I get 2w minus 7x, and that 2 goes away. 4w and 6x have a 2 in common. I'm just going to get it to go right now. 2w plus 3x. So 2w minus 7x. There it is. 2w plus 3x. I had made a mistake in my earlier problem. So 2w, notice that's a positive, so it was a plus 3x. There's another good example of why you should go through your work twice on a test, because it's very easy to make an error. If I checked it, I would have caught it. Doing this extra method, I was able to check my work again. And you can see I have the same answer now. So the big difference when we have these extra letters is just make sure you add the extra letters into your second step here, or in the short method, that letter at the back needs to go at the back of each one. Now your assignment for this one is, again, it was section 3.8 if you want to check out Math Johnson's video if this didn't make sense. But page 194, and the questions are questions 4, 5, 6, 8, 10 to 13, so 10, 11, 12, 13, and number 20, and just do A, C, E for each one. So skip B, skip D, skip F. If a question only has A, B, C, and D, then only do A, C. And it seems like a lot of work. The thing is, once you get good at these, they become really quick. So if you feel like you're going slow, it's because you just don't have it right. So, or you don't have it yet. So more practice, you'll get quicker, and then it'll seem quick.